Okay, next let's look at example 8. Okay, here we have the dielectric of parallel plate capacitor is to be constructed from Teflon that completely fills the volume between the plates. The area of each plate is 0.5 meter square, dielectric constant for the insulator, for the dielectric 2.1. Okay, so kita ada dielectric yang memang sudah diletak lah. Okay, in between the capacitor. Okay, it doesn't say here if it's connected to a battery. Okay, so kita lukis macam ni sajalah. Okay, so here is the dielectric. Given that the dielectric constant 2.1, okay, it completely fills the gap here. Then area 0.5. Okay, first question, we want to find the thickness of the Teflon if the capacitance is 0.1 micro. So, masa dia nak masukkan dielectric ni, okay, capacitance dia adalah 0.1 microfarad. So, kita mau kira thickness of this Teflon. Okay, so basically, since it is completely filled, okay, the gap between, meaning that we want to actually find the gap, the distance of the gap. Okay, value D. Sebab D tu sama dengan thickness Teflon tersebut. So first, okay, kita tengok kita ada ER, kita ada A, kita ada C. Okay, so formula yang kita ada, okay, untuk final capacitance adalah C equal to epsilon A over D. Okay, so you will notice we have a few types of epsilon. Okay, ada beberapa value epsilon. Okay, it's important for you to know the difference. Okay, let me list down. Kita ada epsilon sahaja, dan kita ada epsilon naught, and then kita ada epsilon r. Okay, semua ni benda yang berbeza, tidak sama. So kalau epsilon saja, ini adalah permittivity of dielectric. And then epsilon naught, permittivity of free space. Okay, we call it as permittivity of free space. And then ER is dielectric constant. Okay, so permittivity of dielectric usually digunakan kalau kita sudah dah masukkan dielectric lah. Kalau permittivity of free space is when there is no dielectric. Okay, ini untuk dielectric tersebut. Okay, so dia berbeza dan value ini dia sama. Dia adalah constant value. Okay, constant value you can check from the list, which is 8.85 exponent negative 12. Okay, dia bagi tahu sini free space sebab dia semasa no dielectric. Okay, when there's no dielectric inserted. Okay, so dalam case formula ni, ini formula capacitance final, right? So dia gunakan epsilon, okay, apabila adanya dielectric. Tapi yang dia bagi adalah epsilon r, dielectric constant. So macam mana kita mau relate dengan value ni? Okay, because these three we can relate with one formula, okay, which is epsilon r equal to epsilon divided by epsilon naught. Okay, ini ada formula untuk relate ketiga-tiga ni lah, because they are all related. So kita boleh modify lah kita punya formula ni, di mana let me check first. Okay, di mana masukkan sajalah value formula epsilon sama dengan epsilon r darab dengan epsilon naught A divided by D. Okay, so value mau cari this one. Okay, C ada, ER ada, E naught is the constant one, area pun ada. So masukkan 0.1, ER is 2.1, E0 is at 0.85. Okay, area already in meter, 0.5 divided by the D, the distance. So distance equal to 9.3 exponent negative 5 meter. Okay, please check the calculation. If you get slightly different tapi it's very close to this value, then masih diterima. Okay, next one. Okay, calculate the charge on the capacitor if it is connected to 12 volt battery. Okay, sekarang ni kita mau kira charge. Okay, apabila ada battery lah. So maksudnya, given the battery 12 volt, we want to find Q. Okay, so Q equal to C times with V. Okay, C sudah dibagi 0.1 micro. And V is 12 volt. So just darab dapatlah 1.2 exponent negative 5 coulomb.